All right, hello and welcome to my first video in a while now. Um, and this video is going to be a little bit different. So previously I've done some guides on various things. And in this case, though, we're going to do a little bit of um, a review of this robot right here, the Inspire NC submission for team number 576, Wild White Pizza. Wild White Pizza is hit of a few guys who have done uh, Catathon before and have done FRC before from a couple of different teams. Yeah, so they're cool people. Thank you so much, Riki and everybody else over at 576 for letting me do this video. It's a really cool robot, and I loved digging into it. Um, but you asked for this, um, and this is going to be a pretty. I'm not going to hold anything back on this video. There's a lot to love about this robot. There's also a lot that's messed up about this robot. And before I talk about that, um, I want to talk a little bit about the difference between designing for Catathon and designing for FRC. So, folks on Wild White Pizza have been doing FRC in some cases for a while, and in at least Ricky's case, um, for a while on a team that's very good, 987. So I trust that the people on this team have a pretty good concept of what is successful in FRC. They also know what's successful in Catathon, and those are two different things. And when you look at Catathon robots, you have to look at them from a little bit more critically of a viewpoint if you want to take concepts from them and apply them in FRC. Because Catathon robots can be very successful. This robot ranked third, but also completely non-functional for FRC. Um, and that's not a manner, that's not, in some cases, that's because the designers don't know any better. In other cases, it's because the designers know exactly what they're doing. Um, and I've competed in catathons before, I've judged catathons before. So I can say this: you cut corners on catathons. You make intentional choices to cut corners on catathons to give you to meet the criteria of the catathon, because there aren't any catathons that completely prioritize having a functional robot over anything else. Almost all of them will give you points for strategy, will give you points for looking good, will give you points for the overall concept, etc. And that's just a trade-off that catathons make, because the point of a catathon is to give people design experience. And the reality is, for most people that compete in catathons, um, they just need the experience. And being extremely harsh about whether the robot's going to function or not, and grading people down for whether the robot's going to function or not, um, is often just it's not necessarily in alignment with a catathon's goals, or with any catathon's goals. Um, so yeah. So while I'm going to talk about this robot and I am going to rip it to shreds, um, I'm not, like, it's not out of meanness or out of a lack of respect for the people that built it. I have a lot of respect for them. I've never been talking with them for a while, and there's some great people. So I would highly recommend taking a look at this robot yourself. You can learn a lot from it. They have a fantastic technical binder. Yeah, so now let's dive straight into it. So we're going to start with one of the most um, deceptive mechanisms here. Uh, and I'm not talking about the climber. We'll get to the climber. Climbers were really hard in this Inspire NC game. Um, but they there's a lot to go into with this. So, first off, a little bit about what this game was. Um, so the game was designed around, and it's unfortunate they don't have the game pieces in here. Basically, they had whatever cubes that were nylon stuffed with foam, uh, which is one of the issues with this mechanism. Um, that were supposed to be put into a milk carton, not milk carton, milk crate, kind of like 2018, except for it was all open. So you put those into the crate and then deposited those in a goal. You also climbed a rope that had knots on it. And so the knot climbing rope thing was just awful. And there was like one robot in the entire competition that actually had a climber that I thought would work. So I'm not going to make him too hard, hit him too hard on why I don't like this climber. Um, but yeah, so let's talk about the intake. The intake is, it looks good. It is a perfect example of a catathon thing that looks good, but is just entirely broken. Almost everything about this intake is in some way messed up, and is in some way, but it's all put together in a way that looks very good. So props for that. So let's talk about a couple of the things that are broken about this. Um, so one of the more subtle things that might be hard to notice, is nothing is holding these sides together. So between these two plates, the only thing retaining those side to side is this 1/8 inch aluminum plate. Okay. So let that sink in for a second, okay? All that you are trusting to hold your intake together on this robot is two pieces of, let's check this. 3/4 inch tall, 1/8 inch thick bars of aluminum. That is all that is holding this side to side. This gets hit from the side, these rollers will all pop out. There is nothing retaining them in here other than maybe a press fit. And let's check that. No, that is a dead on 0.875, so not really a press fit. Um, so these are just going to pop out, like, and then you don't have an intake, and then all this robot does is deliver treasure chests and try really hard to climb with a climber that is probably not going to work. Um, Not necessarily because the climbing mechanism doesn't work, but because good luck getting that onto the rope. So yeah, so this guy, so these pop out. So that's issue one with these. Issue two, yeah, these are super thin, which means there's basically nothing protecting this cylinder. That gets hit. This is just going to go into this plate, and you're probably going to bend that cylinder head. Um, you're probably going to get some plastic deformation on these, so you're going to hammer this back into place like every match. And you'll have to hammer it back into place because good luck replacing this bolt right here. This is some top tier catathon stuff. Um, so this guy just isn't going, like, once this is on, it's not coming out, right? Uh, you can do that, or you can remove these 8 bolts, which are probably is going to require, you might be able to get that out with that wheel still on. So that's just going to be a blast. So yeah, so these guys are going to bend. You get take a single hit, um, and all the rollers are going to pop out, and this intake is just going to be broken. Even if it didn't break, though, so let's say that these are infinitely stiff, magical 6061 Like, I don't know, they've wrapped them in unobtainium, and these will never bend, so this will never come apart. And this is just perfect Catathon land stuff. Um, Even with that, this is bare polycarbonate, and the shell of the game piece for this game was nylon. Nylon is super slippery. So the reason the teams did bare polycarbonate on balls in 2020 was because the balls were themselves were super sticky, like extremely sticky. You could do this, right? The game piece, I'm not sure if it's because they missed the type of them, or they read them as that they were foam or something, or if they just missed that they needed a coating on these. But these need a coating. Like, these need, wrap them in surgical tubing. It's a single extra extrude, um, and then you would be able to do that. So those needed coating. So to fix the popping apart bit isn't even that hard. Also, like, you could actually do that. Like, if you were to make all of the parts of this and then assemble it like this and realize it breaks, the only thing that you need to do to fix that really, um, is flip these around, and then even if you had to do this like on site, this is 0.17, which means that you could tap it um, to number 10 and you would be fine, right? So like, this is, that part isn't necessarily game ending. You could flip it around, you do that and it works. They've already shown that they know how to use retaining rings. So if they had caught this, if they were as a like actual team, if they had caught this, like, clearly they could have added a retaining ring, flipped this around, made this a little bit longer, and we're all good. uh, and everybody's happy there. So this is a nice touch here. Um, I love this little offset thing. This is nice and good stuff. So yeah, so this all breaks. There's also something in here that I'm pretty sure, that not sure would be an issue, and that I actually think that they were right to not focus on. But there's a point in here with this intake where you just, there's like a massive gap. It's like, so it's right here, right? You can see, let's grab the side of this so I can see this from the side. So you can see there's a huge, like, there's kind of a huge gap in here. Um, and this may or may not be an actual issue on a real robot. Um, and like I said, I think that they're right to not have like done something drastic to deal with that on this, just because that's, it's the kind of thing that might ruin an intake in reality. But that you can't actually guess on that because there's stuff like momentum going on here that'll carry it into there, and you just, you don't know. So that's kind of a little thing there that concerns me, but isn't that bad. I really like the way that they did this nesting here. Like, this is how you kind of want to do stuff like that. You always want to be careful when you do stuff like this. So you can see here, they have a small issue there in that this is a hard edge, this is a recurve. Um, you're just going to have a fun time there. This might not be able to sit flush if you don't like do some filing or like otherwise mess with this, or trip a hole there, for example. You always want to be careful if you're resting on the bumpers because there's details there that aren't in CAD, like the fact that there's probably bumper wrapping over this. There might be some angle. You want to think about it before you rest something on the bumpers. So those are good. Type packaging on the gearbox. Yeah. So they claimed in their tech binder that this is to something about this, the 4-bar polycarb, one of those things is somehow supposed to help them with head-on collisions. um I don't buy it, and I would have appreciated it if they didn't put that in their tech binder because it's just misleading slash wrong. If you were to do this intake yourself, I would recommend doing these out of polycarb and these out of aluminum, or these out of polycarb too. It doesn't really matter. But like, aluminum's just going to bend, and it's going to plastically bend, and plastic deformation means that you have to hammer things back into place. And you've got a cylinder right there, and that's just like a recipe for a lot of fun times between matches. Utter nightmare to replace this. Um, yeah, so that pretty much covers this intake. I have a lot of concerns with it. It's not on the whole a bad concept. So yeah, let's talk about something that isn't broken on this robot, which is this treasure chest intake. Um, this is actually really good. Like, this is cribbed straight from 2018, and is just like a great call. Like, it's just it's the right choice for dealing with these. Um, this might be a little bit too high there, but like whatever. It's a catathon. A little bit concerning there. That so I mean you can basically dissect this. Like this was the intake for 2018. So like picking this is just it was a good call. They're missing a couple of the features that helped with that. So like part of the thing that 1323, 254, etc. did here is that they sprung load these. They could spring out a little bit, and that helped a lot. With my understanding is that that helped a lot. I can't say that helped a lot because we didn't build one. We didn't. We weren't that smart. My team wasn't that smart that year. But those are supposed to like those sprung out, and that helped it intake it from different orientations, which is really great. So yeah, right call there. Good inspiration from a previous season, like just solid. When this is in its up position, or it's yeah, I think it's this position. So like so this is a retracted position. This is also, I assume, how it's supposed to load. Um, I don't know. Like, I have a hard time seeing on this robot how things get from here to here. Um, I assume that they're just supposed to like stick around here forever. Um, since they didn't put a crate in here, I can't see how much of a gap this is, but it looks like there would be a gap there, which is concerning. It does look like they gave some consideration for where that is relative to this climber, which is good. Um, but in any case, even with it in this position, they're going to have a hard time filling it up to any appreciable amount with treasure chests, just because of the piling action that you would get there. It's going to be a problem. So that's not great. But a lot of the details of this actually are really great. A lot of the issues that they have on this intake were avoided here. These are retained, which is great. I think that all these belt spacings are fairly legit. That's one of the things that people mess with on catathons is belt spacings. It's funny that they used like full detail belts. That's great. They did rely on tapping into this 1/8 inch, which isn't on the whole bad. I might be a little bit concerned about that, but like on the scale of things that you fudge for Catathon, uh, no big deal. Um, there, this joint is nice. I appreciate this joint. I think that they did this joint well. This joint makes me happy as a person. Um, that's how you do that. That's just like this little whatever you want to avoid crushing this tube. You want to um, give it kind of a bushing there to ride on. It's this is good. This is really good. I'm happy with it. And they were very smart about Like they did similar things down here, which is great. And then they like completely forgot about it slash ignored it down here. But we already talked about that. So that's pretty good. Pretty good time. Yeah. Also, like I was talking about the piling on this. The truth is, I don't think that that would be that big of a deal at a lot of competitions. Like it would matter at some of them. It wouldn't matter at a lot of them. Just because this is a fairly challenging game, and whenever you say we have to do one thing to do another thing, that's two things that a team has to do, and a lot of teams only really have the budget for one mechanism. So yeah, um, so I think that they flat out told me that they kind of cribbed this from me. Um, this is a like patterned single part pulley that you could print. Um, so like good for them. I actually really like this design. I love using belts and pulleys now. Um, I just because they're so cheap. Like you can print these pulleys. You'd be able to print these pulleys for a competition robot on a just completely normal 3D printer. You would be able to get these belts for like a couple bucks a piece from V Belt Guys or Polybelt. And so this entire mechanism, like if you're sourcing this from Vex Pro, you're doing it wrong. Because like these belts are just so cheap if you get them from V Belt Guys or Polybelt. So highly recommend that you do that. This bit is a little bit weird. So they're like 3-inch game pieces, and it looks like that's like a little bit of a gap there. Probably not big of a deal. That big of a deal. Also, a good use of tube spacers there with some kind of custom plugs, which is awesome. Good to see. Love to see it. I would feel bad, and I've never done this style. Um, oh, that's mildly concerning for a poly for a belt, um, for a like beanbag type game piece. Um, so I've never done this style for like a real robot. But one of the flaws with it, I would imagine, is that it looks like it would just be a pain to assemble. I can't blame them for this. I kind of started doing this style of mechanism a couple catathons ago, but like beware that you have to assemble this and you have to think about how you're going to assemble it because you also have to do like if you're going to get these tubes in here, you just have some fun times that are going to happen trying to get all these belts in place. It'll take some patience, maybe a few freshman hours to get that done. Let's talk a little bit about electronics. That's the next thing on my list. So one of the things I like about this, I think that these are cute. These little Sparkbacks mounting things that are snap hooks. They're just very cute, and I appreciate them. Um, Whether they would work great or not, different question. But I think that they're cute. I really like them. Um, I obviously they didn't mount any, like they didn't CAD any do or VHB or anything in here, which is a little bit of a shame. But like, um, it's not hard to imagine that there. Also, this wiring harness is just hilarious. Like, look at that clipping. It's beautiful. So yeah, that's all great. This limelight mount, I actually kind of like this limelight mount. Might add like a rib there and there, just a little bit more reinforcement there. It's probably not that big of a deal though. That's mostly like sometimes when you print parts like this, if this isn't on like a Mark Forged or something, you might get some like wiggle there that makes it annoying to if you wanted to view through that for a driver cam. Now let's talk about the worst part about this, which is this breaker placement, which is just depressing. Um, I know you guys know better than this. Like, just take a second to appreciate how bad that black breaker placement is. I know I did. I looked at this and I was just like, oh my God. Like, why would you do this? Especially when you have so much space. Like, it would have costed you nothing to put the breaker like here. But instead you put it in a place where it would be literally impossible to reach. Like, Inspector would hit you so hard for that, and they would be right. Like, sometimes inspectors will come down on you for dumb things. This is a like this is just impressively awful. Um you guys knew better. That being said, it's not like that's a hard thing to fix. Like, whatever. In reality, you zip tie it over here, and then you're happy, and you move on with your life. And the inspectors get to feel good about themselves, and you get to laugh about it afterwards. But like, oh my God, that placement just hurts me. Let's talk about some other more some subtle things here. So let's talk about this drivetrain. So this drivetrain is a chain and tube drivetrain. Good, like chain and tube drivetrains. Um, but you'll notice that there's something a little bit off about this drivetrain, which is that most of the time when you do a chain and tube drivetrain, you do two rows of holes. Why do you do two rows of holes? Because of this. Look at that. You can see chain through that hole. So if you tried to put something in there, you got a problem. And in fact, we can see, if I hide this, we got some interference problems down here. This is super nitpicky for me, but it's also like one of the details that like you skip on a catathon, but on an actual robot will bite you so hard. So on a chain, also these chains are both in the same run, and on a chain and two drivetrain, one of them is going to be on a different run. So that's actually important. That's like genuinely important to do. Um, because that affects how you can mount things and all that stuff. So this drivetrain, congratulations, you managed to make a drivetrain that's problematic. Yeah, that's not great. So I do like this custom gearbox. It's very pretty. They added the nice chamfer there, which is always appreciated. But I mean, I kind of wish you had fixed this from a practicality side. Polycarb belly pan, good call. Um, good call indeed. Good mounting for stuff. Use the Spark Max mounts down here. That's great. Um, yeah, honestly, like other than some details like that, like no big deals here. Um, this bumper mounting's not bad. The only thing I would fix about that is like, so if you're gonna do them on the side, typically what you would do is also like if you literally just screw a piece of angle in over here, um, that keeps the bumpers from like looking sad when they bend inwards due to the weight on the inside. So like you could do that just to make it look a little bit better. Not like they would be illegal in any case, but like you can do that. That'd be great. That would have been good. All right, and then that takes us to the final bit of this, um, which is this climber. Again, climbers very hard for this game. Almost no good climbers that I saw here. And that's for good reason. Like climbing was hard, and trying to do the like tall climb in this game was a fool's errand. It was like 2013 climb, but worse. Like legitimately, I think that it was a more difficult level 3 climb than 2013 was. And this this mechanism doesn't do itself any favors there. Um, it's actually like so to start off, so when you're climbing, one of the biggest parts about climbing is alignment. And they don't seem to have done anything for alignment here, which means that like your aperture for getting this onto something is like the width of this mechanism, which is scary. It's very scary because that smells like a long time to align. And if they can align, it's a fault prone process and probably is going to result in like falling or something because these aren't perfectly aligned, which is what they pretty much need to be to work. Um, Looking like this. This is kind of a clever like friction clutch thing. So like you can kind of see they're different. If you so like you can see basically these they're in position. They kind of like the rope goes around here and here, and it kind of like uses the robot's own weights to stop it from slipping backwards, um, which is cool, like which is nice. There's also a little break here, which is a good touch. There's a lot of good thought that went into this, um, but I still have doubts about it. It's a valiant effort for a climbing challenge that was didn't doesn't really have any parallels in modern or any FRC games I know about. 2017 doesn't count because they let you cheat with the rope. If you tried to climb with the default rope, I'm so sorry that you did that. That just is such a bad thing. So yeah, so there's nothing to help this thing align, which is going to make it really hard. You needed kind of like a V-shaped thing somehow to work in there, and obviously that would have interfered with their chest assembly thing and like having a chest in there. But like, I don't know, they could have figured out a way to do it. And that would have been good because like guiding the rope into this, just like doing that manual driver is so scary. Yeah. But again, really good. Like props for the detailed mechanism. Like there's a lot of nice little details here. It's funny that you chose this one to do all of the like wiring stuff here, wiring and pneumatics. Like that's kind of funny. That's yeah, it's cute. Um, but yeah, so cool stuff. Also like cool details like this thing, which I'm missing what this is for. Anyways, so yeah, nice job, 576. Like even though I kind of ripped into your robot, it was a lot of fun looking at it. And I hope that some other folks that watch anybody else that watches this video can learn some stuff about FRC design by doing it. Thanks. And if you liked this video, let me know on Discord or in the comments or whatever. If you want to do this, reach out to me on the FRC Discord or somewhere else, or in the comments for review. If this is a good thing, I'm totally willing to do it more. And if you want me to be less mean about your robot, I'm okay with that too. Um, Anyways, it's been a blast, and I will see you all next time.